To answer the question of how do we try to solve the issue of multicollinearity, we're going to investigate which of the covariates that are collinear with each other essentially help explain the most variation in our model, and then we're going to remove the other ones. And so we need a criteria with which to assess what are the problematic collinear variables. And to do this, we're going to examine pairwise correlations, and we're going to look for betas that change, so unusual slopes that change either signs or don't really conform with our prior expectations of what we think the true relationship should be. And we'll notice if there's a lot of sensitivity to our betas by removing specific cases. And what we'll do is we'll create a specific measure called the variance inflation factor, which again is just going to be when we estimate a model with and without each variable. And we're going to see what variables, when they're removed, reduce and impact the variation the most. In other words, that R squared value is going to be the percent of variability in our covariate that's explained by all the other predictors. So if there's a variable that has a large VIF, that means that that variable's variation is largely explained by the other collinear variables. And so that is especially going to be problematic potentially. And the way that we get that R squared value, again, is by just regressing whatever, and we'll go through each one. So we'll start with x1 and then regress all of the other collinear variables on it, and then do that again with x2 and x3. And we'll walk through an example here. As a pleasant reminder of how we interpret the R squared value in the VIF, when R squared is close to 1, that means that you can predict that covariate very well with the other predictors. So the VIF is going to be large. It's signaling that it is highly predicted by our other covariates. And again, just as kind of rule of thumb, which I am hesitant to do, but we will kind of use as a guideline, if we have a VIF larger than 10, that's going to be a problematic collinear variable. Now, if it's bigger than 100, that's going to be a really big problem. And the slopes, remember, have specific units. So finding the largest standard error doesn't necessarily mean that you're going to have a variable with the largest VIF.